Let's see. My name's Chris Maddox. I work at ZenPayroll. We do payroll, which is cool. So failure is something that we think about a lot. We transfer hundreds of millions of dollars on a yearly basis, soon to be billions of dollars on a yearly basis. So the percentages for us, like our growth team gets really excited about this. They're like, oh, like billions of dollars, and we're like, please, just like leave me alone. I don't want to know that. The percentages end up being a lot. So today, we're going to talk about failure. And some of the ways we're going to start, we got an agenda. It's like a business meeting, which is great in the business. So we're going to talk about predicting failure, some of the things we've done to preemptively stop ourselves from going down and making mistakes, especially in the area of like database validations and user models and all that stuff. And then talking about recovering from failure, which for us is a really big deal because preventing failure itself is like normally like, yeah, that's pretty cool. But for us, making sure that once something does go wrong, that we don't lose user information. We have a lot of sensitive user information, so we have to make sure that we keep all of that together. And then we're going to talk about embracing failure, which is really weird. But I was a philosophy major, so I'm just going to talk about that. And like, if you like it, like, cool. But if not, whatever. OK, all right, chapter 1. Changes, DHH. I'm a writer now, so we're writing chapters. But my predictions are notably inaccurate. This is Robert Caro. He's a biographer. He's been writing I think, 4-part series on Lyndon B. Johnson for 30 years. I'm 23, so I don't even know what that means, but like it seems like a long time, so I wish him the best. He's really smart. I would definitely recommend checking out his work. So this is something that I've run into actually a number of times on the internet. I don't know if you can read this, so I screwed up the slide format, which is great. There were some problems with your form. Please fix the following errors before submitting again. And then it doesn't really seem to show any errors, which is something that I've definitely, you guys have probably seen this on the web, where you click like save or like submit, and you're like, all right, like we're ready to go, and then you see this red box pop up, and you're like, oh man, like what are they going to ask me for? I don't know. Like I don't know. Whatever those like when they ask you for like those last 4 digits of your like zip code, and you're like, I don't know what the hell that is. Like, why do you ask me for this? I can't validate that. But in this case, nothing really seems to be wrong, and nothing is like actually. There are no inputs that are red. Like very poor UX. And this is what happens kind of as your application grows, as your system grows. Payroll is very complex. We deal with a lot of information, especially on the employee level. So in this case, I manually screwed up Mr. Vonnegut, and I apologize. His bank account information is misconfigured, so he's not going to get paid in the way that he believes that he will. But this presents a problem because the employee model here is invalid, but they're editing a completely different section. So they're going to get these they're going to get these validations on the model, and the user's not really going to know what's going on. And then they're going to call support, and they're going to be really upset, and support's not going to know what to do. I mean, they're going to look at this and like, who knows what's wrong? So this is something that we've run into. Users are prevented from fixing or even seeing the actual problem itself, which is frustrating in the moment, in editing these things. But then, as we'll see later, these kinds of errors cascade to other processes. The main culprits being update column, which is fun but terrifying, and update attributes with validate false, which is like it looks less bad, but it's also just terrible. But these are things that actually, like, they exist for a reason. There are times when these things make sense, especially in, as we'll see, error recovery, when you know that something's gone wrong and you need to save information. We find this with bank transactions. Like, there are times when things have blown up and we need to save information, and if we have to update column and just kind of like snowplow over all the information in there, like it actually makes sense, and we would rather deal with it later. As I said before, like our number one priority is not losing user information, of not losing like an SSN or losing bank account information, losing those transaction details, because that could be on the order of tens of millions of dollars for a single transaction. And so it's just unacceptable that that we don't save the state that they're in. But then that can cascade, and the user is going to see problems. And we want to figure out a way to handle those and to see them before the user actually sees them themselves. All right, this is good. So this was our solution. Validating all of the things. So we have like Rails validations, and those are good. Like in this situation, the UX broke, right? The UI kind of broke down because something went wrong. But there was nothing really wrong with our code. Like it was validating something, and it successfully told us that something was wrong. But the communication was very poor. So what we decided to do, a friend and coworker of mine, Nick Gervasi, suggested this. I remember we were in a pivotal meeting, and he said, well, what if we just ran validations for every model in the database every few hours? And I was like, that's a terrible idea. That'll take out, I mean, we have millions of records already, and we're pretty small. So that was terrible. And I was completely wrong about this, by the way. You should absolutely do this. It's a lot of fun. But it paid its dividends almost immediately by running these validations. So what we did is, right now in production, every 3 hours we validate every single model in the database, and every day it takes longer and longer and longer, and we're just kind of waiting for that to fall apart. But so we pull production data and then validate it against our merged but undeployed code. So we have a development branch that we then merge into master and deploy to production. But right when code is merged in, every 3 hours, we're able to pull production data and either test. This is a good way for testing migrations to make sure that when you run this migration, I don't know if any of you like write tests for your migration. I should. I've never done it, but it's something I aspire to. But it's a good way to find like what are the future errors that we're going to see, or what are existing errors? What are like places where the system, we run a lot of background processes, a lot of very long-running tasks that happen at different intervals during the day, as we'll talk about in a second, that can shift the state of data. And how do we catch those errors before the user even finds out about it? So this is something that we've worked on, and it seems. It was something that, like, the upfront costs are like, wow, like, I'm running this process, and it's taking, 2 hours. Like, that's a big deal. And what happens when we get 10x as big? Like, I honestly have no idea. But I think it's a very good pattern because for the consequences of having it go wrong, I mean, these aren't problems that you're not going to have to deal with. The users are still going to call in. You're still going to have to figure out whatever that bug was, however that happened. But it gives you a lead time in order to solve it in a slow, more managed way, rather than being on the phone with a customer and they're freaking out and you're freaking out and you're in production console. Not that you've ever done that, but like you might have done that. I've never done. We're going to move on. It's not important. Okay, I really like this picture. It's really creepy. But so these are the Precogs from Minority Report. If you haven't seen it, I'm going to give somewhat of a spoiler because you've had long enough, and Tom Cruise is getting old. So these three, I guess they're humans, but like they were like genetically modified. Something happened. So they can predict the future, basically, and they can see, for some reason, they only see murders, which seems like a really terrifying, like that's a terrible power to have. Like it's got to be really depressing. But so they're able to predict the future, so that then people are able to do something about it. Like Tom Cruise like gets all dressed up, and there's like these pinballs and something, and then he like stops the murder, and it's great. So we thought about this, and we were like, how can we, like, more than just validating existing data that's already been janked, how can we figure out in the future, how can we predict the future of what we're going to screw up later? That gets exciting. So this is something that we started. We have these long-running jobs, and that's kind of what this talk is about, is these really long-running processes. There are advantages and disadvantages to working in the space that we do. We work with the IRS, which is wonderful. We're very... their faxed-based API is really, really cutting edge. So that's really nice. Also, working bank transactions. I don't know if you guys know how bank transactions work. It's oh, Jesus. So you decide, like, I want to transfer money. I'm like, like, I got $50 million, and we're going to give it away. That's what we do in Silicon Valley. We just give away money. This is other people's money, so it's okay. We're gonna make this transaction. So first we're gonna make a flat file. We got these like fixed width files, and we're just like typing away, and like, oh, what a nightmare. So then we're gonna FTP it, and we're gonna FTP it to the bank. And so that's okay, cool, we're good, good times. And then you're like, okay, how do I know that it worked? Okay, I can FTP back in and I can check if it worked. Well, but you can't do that because as soon as you put it in there, they take it out. And so you can't even check the inbox to see if it went through. But okay, all right. Well, maybe they'll like send me an email and be like, hey, like, it's good, we got it. Nope. The only way that you know that it worked is if it didn't fail, if they don't tell you that it failed in 2 to 3 days, then it worked. Or you just didn't FTP it in the first place, but like, whatever. So it's important for us to run through all of this information and make sure as much of the things that we can control are under control, before bad things happen. So running a lot of these really big jobs, running through these transactions, making sure that everything is happy before we go through it in production has been really valuable. So now we're going to talk about recovering from failure, and this is actually more interesting. So predicting failure is interesting. Like it's fun, and it's prevented a lot of mistakes from happening in production. But recovery is something that I think we don't put enough thought into in general. At least I haven't, because it seemed like the first approach was, how do I make a more fault-tolerant system? Well, I just don't fail in the first place. Like that, I just write tests, and I QA, and we have happy data in the database, and we have whatever. But it turns out that you're gonna fail anyway, which is depressing. But we get over it. So this is Mia Hamm. Failure happens all the time. It happens every day in practice. What makes you better is how you react to it. I love that. She's fantastic. Mia Hamm is just wonderful. If you've ever seen, there's an ESPN 30 for 30 on the 1999 Women's World Cup team. This is not related to anything Rails related, but it's fantastic, so you should check it out. All right. Anyway, back to in the beginning. All right. So we're going to go way back in time, which is like a year ago, and this was, you get really excited. You start a Rails app, and you're like, Rails new payroll, and we're gonna startups, and here we go, and everything's just really clean. You've got tests and models and controllers, and it's just so exciting. And then you realize that there are all these things that you have to do. Payroll's really complicated. You have to send all these payments to the government. You have to file forms. You have to send all these transactions, and you end up. So we have this system of maintenance, and this was maintenance.rb from 2,500 commits ago. And you can't see the code, and that's kind of on purpose because this is, not what we like. But so basically, I can give you the gist of it. It's a 300-line method that just runs everything. This would run every morning, and it made sense because you could see from a dependency management perspective, you could see exactly where things would run. You could see that they were running in the right order. You knew oh, this should happen before this, and you can rearrange it, and that's fine. And so we would run this every day, and if you got an email like this, we're uh-oh, undefined method shovel for nil class. I don't know. Then you look at the docs, and you're doesn't nil have shovel or no shovel? No. Okay, so no. But the biggest problem here is not that we had an error, because again, we're going to expect errors. We don't really know what we're doing. We're programmers, so we expect errors to happen, but the problem is it happens right in the middle of this. And if this is running for half an hour and then suddenly something blows up in the middle, you have a lot of state that's it gets kind of iffy. And how do you recover from that? I don't know. If you have good ideas, better ideas than instance eval, I'd be happy to hear them. But it was really a sign that this kind of approach doesn't really work. It doesn't really scale. Yes, everything's right in front of you, and that's good, and you can see it, and you can test it. There were a lot of tests around this. But it usually involves a lot of brain surgery. I love the nurse in this picture. She's just oh, God, what's going on? And that's kind of how I feel every day. So why these kind of things happen, and one of the reasons that happens is we have a lot of dependencies. There are a lot of things that we can't control. We have internal, functional dependencies. This is Silicon Valley Bank, the bank that we work with, tons of other banks that we work with. The IRS, which again, they have a crazy system for management. We have internal stuff, tools that we use, MailChimp, Salesforce. External stuff, Xero, QuickBooks, FreshBooks, charitable donations, all sorts of stuff that we integrate with. And those are things that we can't control. And that's one of the difficult parts. If you've been building out a service-oriented architecture, you'll find the same thing, that it's really fun because you have this API and you're oh, there's this thing that I want to do. I'll just make this request, and then I'll just forget about it. Somebody else is going to do the work, and it's awesome. And you get really excited. You start this relationship, and they're going to do all this work, and then they're just going to tell you that they did it, and it's going to be great. But then stuff goes bad. You text them, and they don't text you back, and that was where okay. So we had this situation with the IRS, which was I guess confound. So there are edge cases that we didn't prepare for. I mean, like I didn't prepare for it. I didn't think about it. Where we were just happily like going about our day, and we started getting these emails from HelloFax. I don't know if HelloFax is here. I apologize for this. They just kept saying, they were like, are you sure that this fax number is right? And we were just getting flooded with these emails. Like, are you sure this fax number is right? Like, please check the fax number. We were like, what the hell is going on? Who are we faxing to? Well, we were faxing to Obama. We were faxing to the IRS. And the government had shut down. And that was one, like, we never, like, what? Come on. Like, I didn't know that was going to happen. Like, so they're like edge cases of things that you can't, it wouldn't have been reasonable for us to build the government shutting down into this system. Like, I believe that. I don't know. Maybe I'm wrong. I don't know. Like, prepare for the worst. But, then again, like, if the government shuts down, we were like, well, I think we had a conversation about it once. And we were like, well, like, but then, I don't know, like, fiat currency is dead. So then, like, first priority is implement Bitcoin support. And then we'll move on from there. And so, you got to prioritize. You're a startup, lack of resources, it's a hard life. It's a hard life. So we have to manage a lot of this complexity, especially as size becomes more important. There are a lot of ways that we can kind of go about this. The timing thing is big. I mean, some of these processes, they really do take an hour. And so what do you do? And there are a lot of solutions. I don't know. We rewrite it in C. I don't know any C. Honestly, I don't ever plan on learning it. I think that makes me a jerk. But, like, I'm not going to be Linus, and I'm OK with that. I've lived with that, and DHH said it was OK. So you guys can't make fun of me. HackerNews is really big on Node these days. I don't know. That's possible. We could do that. We could go to Node. They're also really big on Go. HackerNews is so into Go right now. It's just like, what do we do? I don't know. Like, maybe we should just rewrite it in a different language. It's one of those things that, like, programmers get so excited. They're like, new problem. All right, new problem, new language, new framework. We're just going to, what? Like, monads? I don't even know what that is. I still have no idea what a monad is. But it seemed definitely like the right choice. Definitely right. So we didn't go with any of those, thankfully. So we found that for us, and for the way that we need to solve problems, sticking with things that we knew, like tools that we already knew, sticking with the Rails patterns, like general Rails patterns, was very important. Because in those moments, when you get an email that a $40 million transaction failed, you want it to just be automatic. You want to go in there, have everything. That's why for us, code quality actually matters a lot. Readability matters a lot, because you want to take away everything that could possibly go wrong. So step one, here's where we're going to solve it. We're going to break it down. Break it down. All right. So we had this really big maintenance. And so we just started cutting them in half. We're going to have many maintenances. We had one problem before. Let's have lots of problems. So we got payroll maintenance. We got charity maintenance. We're like giving money to charity. That's cool. We got email. We got car maintenance. That's something I have to do. That's not. But we had car maintenance was good. So we split them out into like different like conceptual blocks. So group these conceptually similar pieces, localize the failure. So when something goes down, right? If I can't sync with the MailChimp API with like our newsletter subscription list, like, okay. That's okay. But like, don't let that stop somebody getting paid. That's not like, I don't know. Both are important. Newsletters are important. You should sign up. But some things, we should localize those. And the problem that we found, some of the cons, the domains are still very large. And I know we can break down into like service objects, and we can just go objects on objects and on objects, and that's, we like it, and it's good. But like, there's still a point where like payroll, like running payroll, there are a lot of things that need to happen, and conceptually, it makes a lot more sense keeping them close together. We still also have this idea of failing in the middle, which is terrifying. And just requires a lot of manual work. And as programmers, we like to get rid of manual work. Like that's our job. So we're gonna break it down some more. Look at these steps. Look you go. All right. So I wrote some code. So we developed this library called Ultramarathon, and I'll just kind of give you like a brief overview because I don't know if that's fun. But I just wanted to give you a sense of like it's a very Railsy feel. We've got callbacks, we've got like lambdas and like stabby stuff, and like that's cool. But we were able to create a DSL where we were able to map out dependencies. We were able to have all of these things basically conceptually break them out in our mind, which for us was very important. The readability, the being able to tell what failed and where exactly it failed and what other things relied on that was very important. So we have just like a general life cycle. This is also very Railsy. Before run callbacks, we then run it. We have things that might happen on an error. And then once something does fail, we have to be able to reset it, get it back into kind of a happy state, and manage the state as we reset it, and then do things after it runs. So that's just kind of like the general life cycle of these maintenance objects that we created. And then confusingly named Ultra Marathon because Marathon was taken, and I think it's like gem squatting is rampant. But if you own that gem, I'd love to buy it. So this is generally how it works. So we broke them down into these like running blocks. So these are all unrun. Then we run them and things fail as we expect, because we're not very good. But that's okay because only we have these partial failures. So instead of one thing basically blocking and just blowing up and now everything's gone to hell and having to like revive that state, we can now run them and have individual pieces succeed and individual pieces fail, and their dependencies don't run if the parent failed. But that's okay. We can reset them, and we're like, oh, okay. So instead of just losing all of the work that we did and trying to figure out how do we not pay people multiple times, which they might like. That could be a feature in the future, but for now, no. And then rerun them, and they're all green. And that was like the most simplified version of like an actual code example. Anyway, you can look it up on GitHub. So advantages to this, definitely instrumentation. That's really important. There are it's important for us to be architecturally sound and like conceptually understand what's happening. But it is also, as we grow, needing to instrument stuff, needing to figure out why does this take half an hour or an hour long? Like how can we have this grow 10 times as large and take half the time or whatever? And that may involve, the technologies that I mentioned earlier, I don't have anything against any of them. It's definitely possible we'll have to rewrite things in C, and definitely on the tax side we do. And we may use other languages and other frameworks. And then the quarantine failures was really important for us. And explicit dependencies. There are things that have to happen before others. And so this gives us a very good kind of mental framework for allowing things to fail and not bringing everything down. And the things that succeed, it'll run as far as it can. And if things fail, it'll keep doing the things that it can. But that gives us less manual labor that we have to do. Because again, if it runs for an hour and it fails halfway through, we don't want to have to start over, because then we have to wait another hour for it to maybe succeed. Chapter 3, accepting failure. It's like something my dad would talk to me about. Chris, we're going to talk about accepting failure. He's a nice guy. I really like my dad. So this is kind of where we started. We started this journey. I think we put ourselves under a lot of stress, and maybe for the right reasons. We deal with a lot of critical stuff. And I don't mean that like an arrogance, like, oh, we're doing all this cool stuff. I mean it like the things that happen were we to fail are pretty bad. And they're pretty bad, like, not just for us. Like, I'm okay. Like, if I screw up and, like I don't know, like, I break some tests or whatever, like, I'm okay with that. But some of the mistakes, like, if people might not get paid, and people not getting paid on time for us is a really big deal. People might miss rent. That terrifies me. Like, the idea that somebody would miss rent or would have to take out a loan. If you know anything about, they're like short-term payroll loans. It's a revolting business. They charge like 20 or 30% interest on people who have like already earned their money but like don't have it right now, and so they'll just charge them absurd amounts of money. So like if we put somebody in that situation, that's terrible. So we started from it. We were like, this is so serious. We're dealing with huge volumes of money that is not ours. We're dealing with other people's lives. We're dealing with, like, if the IRS comes back and is like, you didn't submit this payment, and they'll send notices to these small business owners, and like you're a 3-person like flower shop, and you get this thing from the IRS. It's like, you owe us money, and like you're going to be fined. I think some of their fines are like 10x whatever you missed. Like, that's really scary, and like part of our role is to mask all of that complexity, to like make it happy, like make it, butterflies and payroll and stuff. So we took a very serious approach to, like, failure is not an option. We cannot fail. We can never go down. And we started out with kind of believing that was the number one priority, that we never failed. And I think that was not right. And it took us a while to kind of figure that out. That like maybe that's not the direction that we should go in. Because ultimately, to say that failure is not an option is not actually itself an option. I mean, we're people. Like, we build software. That's what we do. But we are ourselves flawed, and we're going to write bugs, and, like, the IRS is going to go down. Like, you can't rely on everything always being happy. And so believing that that is going to be the state of the world and trying to prepare for every single error case was not realistic, especially as things grow, as they tend to. We're going to look at some quotes. That's good. You're afraid of making mistakes. Don't be. Mistakes can be profited by. Man, when I was young, I shoved my ignorance in people's faces. They beat me with sticks, which seems like a weird reaction. By the time I was 40, my blunt instrument had been honed to a fine cutting point for me. If you hide your ignorance, no one will ever hit you, and you'll never learn. Ray Bradbury, I think this is, I don't know what this is. Fahrenheit 451, I think. I really like this. And it took us a while to get to this point where it's like failure is okay. Failure is something, and this is less about this particular case, less about like programming in general, but I think we have, like, this is definitely a thing, like in society, like we don't like to fail. We like objective measures of success, of like, we like money. We deal with money all the time, but we like to view ourselves as like we have grades or we have like test coverage. We have like all these things that say like I am successful, and then we don't want to fail, which is good. Like I think we should continue to push ourselves, but the failures are often the times where we learn the most about the area that we're in. Definitely in payroll. Like our failures have taught us more about how to build this system than if we had been extraordinarily slow and careful and just never allowed ourselves to make any mistakes. Because ultimately the mistakes were going to happen anyway. And so you could view it from a sense of, oh my God, this happened, everything's on fire, like I have to make sure that this doesn't blow up. But like if that's going to happen anyway, the learning from it is far more valuable. You're going to get far more out of it. I think there's also this misconception that there are people who don't fail. Good people are not those who lack flaws. The brave are not those who feel no fear, and the generous are not those who never feel selfish. Extraordinary people are not extraordinary because they are invulnerable to unconscious biases. They are extraordinary because they choose to do something about it. I think the unconscious biases, like you can substitute that for anything. I've seen this a lot, especially in programming. Like dealing with failure. Like we see people working in SF or just being here. Like you see like Yehuda gives a talk, or like DHH gives a talk, or like Tenderlove gives a talk. You're like, wow, like these are people that I really respect. Like I see them go out and write code, and then I look at myself and like I just committed something with a syntax error. And like, oh. Like maybe I'm not going to be that person. Like maybe I can't do that. And I think that was really hard, like especially when you start working in a business. Like it's a personal struggle, definitely, to accept these kinds of failures. And when you work with other people, it's even more of a struggle because you're like, now I have these people that are relying on me. Now I have people who literally their livelihood relies on me not fucking up, and that's terrifying. But I think to hold yourself to that idea that we're never going to fail is itself a recipe for failure. Like those, like Tenderlove, like I'm sure the number of times that he's made mistakes are like unbelievable, uncountable. I won't speak. Maybe he's never made. I don't know. But I think like it's very strange to me. I think we have this thing called imposter syndrome, which is like I've only ever heard of it in investment banking. Actually, I've heard of it, and here. Which is weird because they're like completely different things, right? Like investment banking is like all about money. Like we're just going to, whoever, like we'll bring down the economy maybe by accident. And like I don't know anything about finance, so don't listen to me on this stuff. But like completely different motivations. Like those are completely different people. Like they wear suits, and that's terrifying. And like they have really nice hair, which is like I'm jealous. But like they're completely different people, but also have those kind of insecurities. And I think we definitely have that. Like. Even some of the best people that I've spoken to, some of like these programmers that I respect more than anything, and they'll say like I just feel like I'm not good enough to be where I am. Like I feel like I don't deserve it. Like people ask me to talk, or people will hire me for jobs, people will give me respect, and I don't deserve it. And I think part of it is this idea that we work with computers which never make any mistakes. I mean, in general, they do things only that you tell them to do. And they empower you to make mistakes on a far broader scale than you could ever make by yourself alone, which is good. That's fun. But I think this is really interesting. So I was wondering I submitted this proposal, and some people asked me like, "Oh, you submitted RailsConf. Like, what are you talking about?" And I was like, "Error recovery in long-running processes." And they were like, "Oh, cool." And I was like, "Yeah, I don't know. I'm like really jazzed about this, but like I don't really know why." And like I keep telling people I do. Like when I talk to people, and like if you've ever been in a bar and been like, somebody's like, "Oh, what do you do?" And I'm like, "I work in a payroll company." You're like, "Ooh," and they're like, "Oh, I'm sorry." Like, no, I love it. Like, this is so exciting. Like, you get to like do you can empower people to do whatever the hell they want with their money. Like, if they want to donate, like you can impact billions of dollars. Like, really, really jazzy stuff. But I think with this, it took me a long time to figure out, and actually, like, the talk was already accepted, and I still hadn't figured out why I wanted to do it, which was a problem. Definitely a problem yesterday. Didn't finish this yesterday. But I couldn't figure it out. And then I was actually talking with my dad, and I figured it out. And it was this. It was failure. Like this, I think if you take away anything from this, and you can look at the code, and there are a lot of like the libraries that we wrote, and I'd love to talk about the technological problems that we're solving. But I think the failure piece for me was really what I found attractive, the shift in philosophy that we needed to have. It was healthy for us to accept that we are going to fail, even though we're doing very critical things, even though we have people's livelihoods in our hand, to assume that just because we would like to not fail, that we are not going to fail, ultimately just caused us to have a lot of stress. And every time something did go wrong, we were like, oh my God, this can't happen. Everything's on fire. Everything's fucked. But that's not ultimately better for our users. It's not better for our own sanity and our health and our loved ones and the people we interact with every day. So I don't know. I think if you take anything from this, it would be to fail more. So if your company's paying for you to be here, don't tell them that I told you that, because that's probably, I don't even know if my company knows that I'm going to say that, but that's okay. So if you want to learn more, it's on the github.com. Broken Record is a system that we use to validate all of our models. There's a lot more things around that, around threading, around performance, because there's obviously many more considerations that you have to have when doing that. Ultramarathon is a system that we use and have open source and are still actively working on. I mean, I can't say that we've solved this problem, and we will continue to work on it. But to run a lot of these really big jobs, to allow things to fail, to allow things to be able to recover them and roll them back and like get things into a happier state. And then performance is something that we'll definitely work on there. So that's, yeah. So if you want to learn more, definitely check it out. And definitely, you don't have to just think about the philosophy, because don't worry, I stay up late doing that, which is fun. So yeah, I guess we have time for questions. If you have questions about anything, coding or not coding related, I'm happy to talk about anything. Anything else? All right, thank you.